Welcome back, Generals, to another Let's Fix Generals 0 Hour to make the best game ever. Okay, what do we do in this session? Probably not much. Let's see. What do we have here? Building a power plant. There seems to be a confusion about what this change is about. I think people read the title of the issue as remove production speed penalty. And that is a controversial topic that tends to spark balanced discussion. This is, in fact, not why I opened this issue. Perhaps the title and description of this issue should be adjusted. Posh. Aha. Yeah, that's what I thought, but it's just a minor issue, isn't it? That's just a really minor thing. If you get a power plant and it just snaps forward the time a bit, what's the big deal here? To me, this looks like a minor issue. Or no issue. I mean, intangible impacts on any match. Building a power plant without power consumption instantly decreases unit build time. Without power consumption. Building a power plant without power consumption instantly decreases unit build time. I really don't understand why this issue is a big deal. It's such a minor thing. Is it even an issue? I don't know what to say about this. I'm skeptical that there are top-level players chomping at the bit to discredit the movement despite all the great advancement achieved so far on the horizon. If anything, they would surely discredit themselves for making a fuss of it. I'm certain that nothing bad would come of this fix being merged, and revision or amendment are always options if necessary. If we absolutely must remain beholden to the anticipated opinions, then we can revisit this if when such opinions have been expressed. Ugh. Yeah, but... Yeah. Hmm. 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 Yeah, I don't know. I don't know. Hmm. Vote to kick leggy observers. Observers need to be implemented in a way that they are more passive. I don't think so, as horizontal and vertical scroll speeds are still different. This change just corrects the awkward aspect calculation for different aspect ratios. Okay, for example, that get height returns 960. This leads to a view aspect value of 2. After hiding the control bar, get height returns a full screen height. However, before this change, returns a screen aspect of 1 instead of the expected 1.6. Oh. This has the effect of halving the vertical scroll speed when hiding the control bar. Oh. I see. Below is a table of common screen resolutions in the expected screen. Uh-huh. Uh-huh. Mm-hmm. Mm-hmm. I see. Mm-hmm. Mm-hmm. I see. Mm-hmm. correct viewport vertical scroll speed. Okay. Bug fix, scrolling, fix vertical scroll speed, bug, fix with different aspects, ratios. Discrepancies. Let's give this a try. Fix. What is it? Fix viewports. Viewports. Okay, so in this resolution. Interesting. Maybe it would be better placed in a observer specific view. Better suited for an observer specific display. Yeah. I didn't mean to start the world builder. Okay, so scrolling. Now let's change it to this resolution. To me, it looks like it goes faster when the viewport is smaller. So it's still not right. If we were to change the um, let me search for toggle control bar. Toggle control bar. Here, set scale viewport height. Let's set this to let's set this to very small height, 0.2. Yeah. Okay, and then this doesn't look as I expected it to be. Okay. So the stuff you changed was scroll by. Why is this gray line here? What is this? Can disable generals. Let's enable debug as well. Tools. Aspects. Why is this scaled by aspect? Oh boy, okay. Okay, I don't understand why we're not getting the... toggle control bar. Oh, we changed it in generals, that's why. Of course. Okay. Okay. Skirmish. Okay, that's exactly how I expect it to look. Okay, so the scroll is pretty fast. Pretty fast. Yeah. So this is super fast. Yeah. And I don't know why it has to be this fast. It makes no sense. So if we make it full, now it's slower. Yeah, why is it so fast? Okay, so if we go into this code, scroll by. So we put a breakpoint here. Then we see the aspect is 8. And so it will scale this by 8. The question is, why do we want to scale this up then? How does that make sense? Let's set a let's get a breakpoint here. The horizontal scroll speed factor. Let's hack that one. Let's hard code that to F. Well, I think the original is 2 and 1.6 for the other. So let's do the 1.8, yeah. I use the writable global data, okay. And then we check if the scroll speeds we check if the scroll speed is now identical on both axes. Yeah. We also can test with different pitches, camera pitches. So, oops. Okay, so now the speed is super fast. Now we do this, and now we should have the same speed in both directions. And to me, just eyeballing this, it looks fine. Now, if we do it with the keys, I think that's a bit better. And it looks, to me, it looks pretty identical, right? Okay, now if we change the camera pitch to maybe it's like this. Aha, now we have a problem because now the scroll is faster. And if we do this, then the scroll is slower. Yeah, I remember this bug from Gentoo, and I fixed it somewhere. Somewhere we need to, let me see that bug. This one. So basically I recalculated the vertical scroll speed somewhere with this formula. Screen aspect ratio of 1.6 and higher with double vertical scroll speed and regular viewport. This is probably referring to the bug. Compensate by scaling vertical scroll speed accordingly. Does it work? Yes. With double vertical, okay. Okay, I think this behavior was caused by this calculation with the rounding error that Stubiak has found. Okay, so we don't longer need to do that. But then there's another here, this one. Adjust vertical scroll speed to camera pitch. Camera pitch. How do we get the camera pitch? So I think what we need to do is we need to remove this guy. And then we need to... how do we get the pitch? Pitch. Camera pitch. Here, global data camera pitch. Is that the one? Oof. Pitch. I don't know. Pitch. Camera pitch. Where's this used? It's probably, I don't know. Camera pitch here. Yeah. Camera pitch. Camera pitch. Pitch camera. What about this one? Pitch camera. Pitch camera info. Angle. Pitch camera 1 frame. Okay, and what is it setting? FX pitch. What is this? Camera effects pitch. Oh boy. Okay, let me search for, let's go to Command XLUT. Search for pitch. Not found. Message pitch. Here. Begin adjust pitch. Let's search for this guy. Is pitching. Is pitching. Okay, what is that doing? Set pitch. Aha. Tactical view, set pitch. Okay. Okay, and then I guess in the tactical view there is also a get pitch. There is. Okay, fantastic. Then we do that. Let's go back to where we started. Where's that? Oh boy. Where are we? Here. Okay, let's put a bookmark here. We already have. Okay. And so we need to multiply. So we have the tactical view. Tactical view, get pitch. Yeah. So we have real pitch. Camera pitch. Const. Okay. Then, so that was h speed divided by that. Okay. Okay. So it's end x divided by sin camera pitch times pi divided by 180. And so this will be the y modifier real const y modifier camera pitch y modifier, and then we need to end x scroll resolution. V speed, adjust vertical scroll speed. V speed. Yeah, I think it doesn't matter when we scale. What does it matter? Uh, Question is, what is h speed and v speed here? V speed by considering Cambridge. What is V speed? V speed. Is it this one? Oof. What is h speed? Set scroll speed. Okay. I really don't know what this here is. Set scroll speed, h speed. H speed. Maybe we can just do 1 divided by this. I'm really not sure. I'm not sure why we divided, why we use this here. Probably just use 1 then, yeah, I guess. Yeah. Okay. Oof. Oof. What? Something ain't right here. Infinite. Oh, camera pitch is 0. What? Camera pitch is 0? How does that make sense? Pitch angle. Huh? How's this 0? Is it because we never changed the pitch yet? And then it's 0. Oh yeah, that could be. So now it has a value. Okay. So now it makes a huge value. Camera pitch. So that's quite a bit too fast. Okay, so there are multiple problems still. Okay. Scroll by. So what are the values looking like? So this one, delta y is 0. Okay. 0 minus 6. Okay. Okay, so minus 55, 0. Okay, so let's take a look at this value. So I moved a little bit up and it says minus 55. So if we change the pitch to like a low pitch like this, what happens then? Minus 76. 66. Let's use a full viewport. Minus 66. Okay. So if we change it up. Okay, now it's not moved. Oh, it's inverse. somehow. Minus 65. Okay, so it looks like the deltas we get is very similar. Yeah, no matter the pitch, we get round about the same values here, depending on the frame rate, likely. Okay, so this input is fine, and y. Start, end, start, y, delta. Device to world space. Let me test it one more fresh. We need to identify the correct problem first. Yeah. Okay, so certainly the problem is when the camera pitch is low, then the movement is very little. And when the camera pitch is high, the movement is fast. Right. There's an error. Why? What's the error? Oh, of course. Okay. So if we lower the view, now if we scroll, we move very, very slow. And we put the pitch up, we move pretty fast. If we move the camera very, very low, we move almost not at all. Very slow. Okay, so it's some... Where does this issue exactly come from? So this is fine. Right, let's double check this. So we put a breakpoint here and... Oops, I didn't mean to do that. And we put the breakpoint here, and now we move the camera, and now we have -43 here, which is probably fine. Yeah. Okay. Okay, and then here it will do... Why can't we see this value? What is going on here? World starts. World end. World starts. Why? World. Okay, so this value looks very, very small now. The Y value. Okay, let's say we move it up a notch, and then we put the breakpoint here, and now we move it, and now the Y is significantly bigger here. 7.5. Yeah. Before it was under 1, right? 0.4 before. Okay, Z is 2. Device to world space. Why does it do that? Device to world space. Device to world space. I think I suspect what it means is so you have this XY, this here is in this is in this is in screen coordinates, this Y, right? And so we now need to translate this into world coordinates, how far we travel in the world. Yeah, and when the I think device to worldview is wrong. It shouldn't take this transform, but it should take a top, like a bird view transform. Yeah. Device to view space. What is this transform? Is this a matrix or what is it? Matrix, yeah. Yes. Device coordinates, world coordinates. So how about instead of this transform, we give it a transform vector device. Do we have any other function here? Device to world space. Viewpoint is at 0, 0. And the view plane is at z minus 1. View space. View space. 3D space where the viewpoint is at 0, 0. And the view plane is at z minus 1. I don't understand what that means. Z minus 1. Does it mean it looks down or not? Let's look at the code. Target resolution. View space rectangle which corresponds to the viewport. Mapping from the viewport coordinates to view space coordinates. Z minus 1. To view space. Okay, what happens if we just use device to view space? Let me just see that. So I think the problem is that this transform here, this transform, if we have the camera pitch low, then it translates the y-axis of the screen to a very like small patch of distance, because yeah, if you move up, you don't, well, actually I would expect the reverse, that it moves super fast. And okay, I don't actually understand the problem, but let's test anyway what happens if we call view space here. Let's see what happens. Okay, I don't understand the problem fully. The mass issue, I mean. Yeah, I don't know. I need to study how this works exactly. Can probably ask AI to help a bit and see if it can explain it in simple terms. Yeah. So we move it down, and oh, that actually feels okay. Okay. Huh? Is that already the fix? I don't know why it would fix it, but it does fix it. Okay. Well, that's fair enough. That's fair enough. Okay, so that feels good. And that feels good as well. Yeah. Okay, I don't fully understand why though. So that's a bit upsetting. But it works. Yeah, I suspect that this transform here for the world space, it screws it up somehow. This one here. Yeah. Transform projecting points between various current systems. 3D space where the viewpoint is at 0, 0, 0 and the view plane is at z minus 1. So to me it sounds like it's looking down. Let me ask ChatGPT to explain these here in simple terms. New chat. Can you explain these two functions? Got it. This function converts a 2D pixel position on the screen, device coordinates, into view space coordinates. Get render target resolution, retrieves the size of the render target in pixels, yes. Normalize device coordinates, yes. Converts from pixel coordinates into normalized device coordinates. Get the view plane extends. This gives the rectangle in view space. The rectangle in view space. The camera's 2D projection plane at z minus 1. View space. Okay, I need to inquire about this here a bit more. X maps linearly between vs min x and vs max x. Y is flipped, not a subtraction. Y is because y grows downwards, but view space y grows upward. Z is set to -1, placing it on the view plane in front of the camera. Placing it on the view plane. Near projection plane. Converts from device coordinates to world coordinates. Camera's inverse view matrix. Can you elaborate on this? you elaborate on to the rectangle in front of the camera, where every screen pixel corresponds to a 3D point. It's a mathematical device that links. Is it? Yes, give me an illustration. Okay, Y is up. Is Y up? Looking down. Camera at origin, looking down. So, okay, right side. Is this a top-down view or what is this? Can you tell me? I mean, is that is this a top-down view? No, it's not top-down. You're standing to the side of the camera. Camera. How does that make sense? Why is this? Why is Y and Z on the same axis? What is this? Am I stupid or what? Why is this on the same axis? I don't get it. So, okay, X, fair enough. Z minus 1 is the screen plane. Okay, so he's just talking about the screen. So XY is just like what we see on the screen, and then Z would be like into the monitor. Yeah, or minus 1, or to me, like to the viewer. Okay. Y grows downwards, but view space Y grows upwards. The pixel coordinate XY on screen is converted into a 3D point on the camera's view space. Aha. Okay. Okay. So huh. Okay, so let's ask ChatGPT. Let me remove all this here. So I have this function here. So I have this function here. So that was world space, right? So I have this function here, and it does not work right when scroll when the camera pitch is low to the ground. Does not work right when the does not scroll properly when the it does. Let's say it scrolls too slowly when the camera pitch is low to the ground. Changing from device word space to changing the calls from device to view space fixes the issue. Why? Yeah, I would like to understand. AI can probably explain it. This makes a lot of sense once we connect the dots. It takes a screen space delta, yes, and maps two screen points, start and end, into 3D space. It subtracts them to get a scroll vector and world space. Then applies that to camera's world position. Then applies some camera, yeah, the ground plane. Device to world space. This function converts screen chords to world space using the camera's full transform. If the camera is pitched downwards toward the ground, the movement along screen Y translates into a vector that's mostly pointing into the ground. Negative Z. Aha. Not along the ground plane. The code then discards world Z and only applies world X, world Y. That means you only get a small horizontal component of the intended movements. Does it mean vertical components? The more pitch the camera, the smaller this horizontal component. Scroll feels slower. Did I write? It's not the horizontal one, it's a vertical one, but okay. This instead converts screen chords view space with this camera relative. In view space, the camera is always looking down. Aha, the camera is looking down. Okay, so it does work like that. And X, Y are aligned with the screen. Okay, yeah, that makes sense. So the delta maps to a consistent offset across a plane at z minus 1, regardless of pitch. So it is looking down. It is looking down. Okay. That makes sense, yeah. The result is a uniform translation that doesn't shrink when the camera tilts. This feels constant and natural. Ignores the world orientation. It just uses the screen's camera local basis. So the scroll speed is independent of pitch. Okay, let me see what happens if we rotate the camera. Aha, but then it doesn't work correctly. Aha. Okay, so it's not the complete fix yet. So it works correctly when we don't have any rotation, but it breaks when we rotate the camera. Then it doesn't move right. Okay. So we need to rotate the camera. So I think what we need to do is we need to device to view space, and then we need to rotate this guy. Matrix 3D. In the matrix, can we get here? Rotate. Get X rotation, get Y rotation. Approximate amount of the matrix. Can we transform matrix? We probably need to build a matrix from the rotation angle, right? Set transform. Yeah. How is this thing rotated then? By what? It is probably this one here, set transform. Wait, is it render object class? No, it's camera class. Why is it going in here? What is this? Why do I jump from camera class to... What is this? From camera class to render object class. What is this? Camera class. Hold on. Is the camera class a render object or what is this? Oh, it is. Okay. Well, there we go. So So someone sets the transform of our camera. Let's put a breakpoint in there. How about that? Here, set transform. Camera inverse transform. Oof, what is this? Set the transform of the camera. Set transform. Okay, there we go. Let's put a breakpoint here. Let me route. Oh well. Hot reloads. What is this? Okay, put a breakpoint in there. Okay, somewhat is calling it. Set camera transform. Oh Jesus Christ, what is this? Build camera transform. So we have zoom, angle, pitch. Oof. Well, that's a lot. Okay, so there's a lot going in there. So we probably need to. I'm actually surprised that they use matrices for everything instead of quaternions. Problem is the matrix, there are probably a lot of gimbal lock problems in there, no? I mean, how's this supposed to work if you have the gimbal lock? Well. Okay, so to me it looks like we need to cancel out the pitch. The pitch. So give you the approximate amount that the matrix has been rotated. These functions cannot be used to rebuild a matrix. Convert a matrix. So you can't use it here. X, Y. So basically we're only interested in the Z rotation, right? We're not interested in X, Y. Yeah, just Z rotation. I think. Oh yeah, let me try this here. I'm really not sure if that will work. So we have these guys. And so we will transform the vector. Yes. Yes. Transform. So matrix 3D transform. Okay, so here we have a get transform, yeah. Okay, and this gives us a matrix, yeah. Okay, so const matrix 3D transform, camera transform. Okay, and then I don't know why it writes here in green all the time. What is this? Is it because of this bullshit here? Somehow something is wrong here with the way it colors these texts. Like, why is this const green here? What is this? Why is this green? Okay, so transform vector. Oh boy. Camera. Let's say we need Y and create a new matrix Y. Actually, no. Let's do a float Z dot get Z rotation, and then do matrix Z rotation const matrix one true Z dot rotate Z Z. Maybe we can just pass this here. Okay, and then we do the Z rotation, and then what is this here? World end. Let's do vector 3 view and then view this view, and then world ends. Where's it? It's a vector. Oh, we already have it. Never mind. World ends. There we go. Okay, I've actually no clue if that works the way I expect it to work. Basically, I would just want to extract the Z rotation from the camera transform and just rotate. Well, yeah, just rotate. I'm not sure if that works. Probably won't. I think this game really needs quaternions. Okay, so scrolling doesn't work at all anymore. That's fantastic. Good. So it doesn't work. Good. Yeah, I need to study this more. So I guess it's always 0, or what happens? So rotation is... Looks like it's identity matrix. Yeah, so we didn't rotate anything here. Okay. Oh. I think we made a mistake here. Start. Let's call it start, view start, view end, view start, view end, view end, view start, and world end. World start, I mean. Okay, does that make sense? Well, probably not, because the rotation does nothing here. No. Because we didn't rotate the camera yet. Okay, that actually makes sense. Okay, let's rebuild this. Okay, so okay, so that works, yeah. Now we rotate the camera, and that also works. Okay. Okay, so that actually works. Look at that. Okay. Oh, that's cool. So we are not as stupid as we thought we are. Okay. So basically what we did now, we just extracted the Z rotation from the camera transform, and we just rotate the vectors by this Z rotation, and we ignore the XY rotation, aka the pitch, right, of the camera. Just a Z rotation. I don't know if that's the most efficient way to do this, but it kind of does what it did before. So before it would transform here with the full transform, right, including the X and Y component. Yeah, so work-wise, it's kind of the same deal. I don't know if there's a more efficient way to maybe say, okay, we I think it's fine. Yeah. Okay, well, it makes sense. Yeah, makes sense. Can we make this a bit prettier though? What's the time? Oh, it's actually already quite late. I think I will take a break here. The next session we'll pick this up again and finalize this. But yeah, it looks like this is a fix. I might need to test a bit more, but this already looks very promising. Yeah. Yeah, it looks good. It looks good. I'm surprised by the low performance on this low pitch here. Interesting. Okay, well, it looks very promising. Good. All right, I will take a break here. I wish you a great day or night. Until next time. Goodbye.